I'll briefly demonstrate how to use digital experiment that's a model of a continuous stir tank reactor. The reaction is shown here, and what we're going to do is carry out mass balance in order to determine the rate of reaction, and then also the order of the reaction. Now, this experiment is located in the LearnChemE site, the link's given here. A snapshot of the digital experiment is shown here. So notice a couple things. Have to carry out the experiment in a certain order, namely, we first set a temperature with this slider, set concentrations of the two reactants in the two feed tanks. We then turn on the stirrer, and then next we set these valves to some percentage opening, and then turn on the two pumps for the two feed streams. So keep in mind, in this case, I have a 0.3 molar of each reactant. So we mix them together. If we're at the same flow rate, then the concentration is 0.15 molar for each of them entering the CSTR. The measurement of the product concentration are two sensors that measure product concentration that are shown here. And notice that it says the transient speed is sped up a factor of 10. That means we'll get to steady state much faster than in a real experiment with these particular dimensions. And that's just to save time in running the digital experiment. The other thing is that the reactor is greatly expanded in size. The reactor volume is 1 liter, and 1 liter is the volume you can see here in these feed tanks. So this is greatly expanded just to make it easier to see. So let's look at this interactive simulation. So here's the interactive simulation, and notice that the idea is we set the temperature and the feed condition, so reactor temperature, and we'll keep these the same. Now we start to stir, just to represent that it's a well-mixed system, and then we pick some settings. They don't have to be the same flow rate by any means. And then we click on the valves to open them. Now reaction starts. System will reach steady state, and we sped up the time just so that the digital experiment can be done in a reasonable time. So this is showing the concentration of the products, and the idea is that we can measure flow rates by measuring the change in the volume, and by using the scroll wheel and then dragging, we can expand these, and so we can use a timer to more accurately measure what's the volume change as the reaction proceeding. Remember, this is at steady state. So we have a reset button that gets us back to starting conditions. We can pick different temperatures. We also have directions that tell briefly about the simulation. And then we have a worksheet, which is detailed directions, a PDF file to download that tells the steps to take, describes the experiment, etc. And so the idea is we can make measurements and do mass balances and determine information about the rates of reaction.